Okay, so for the fourth tutorial, we're going to look at exponents. So before we do any real examples, we're going to go over the rules of how you work with exponents. The first ones have to do with when you're multiplying two things and they have the same base. So for example, let's say we had a to the power of m, so we're just doing this in general, times a to the n. The rule is that we can combine those together and add the exponents together. So off to the side, if I was to do an example of that, so if I had 5 to the power of 2 times 5 to the power of 3, then that is the same as 5 to the power of 2 plus 3, which is 5 to the 5. Okay, so the second one has to do with dividing. So if I had a to the m divided by a to the n, then instead of adding when we combine, we'd be subtracting, so it'd be m minus n. So if I did another example with that, I would have, let's say, 2 to the power of 6 divided by 2 to the power of 4 is 2 to the 6 minus 4, which would just be 2 to the power of 2. If we have an exponent on an exponent, so let's say I had a to the m, and we take that whole thing and we want to multiply it by something else, the rule is that we multiply them together. So it becomes a to the mn, which is, remember, if we have two things beside each other, that means multiplication, so that's m times n. So if I had 3 to the power of 2 all to the power of 3, that's the same as 3 to the power of 2 times 3, which means that that's 3 to the power of 6. If there happens to be another value in there with it, so let's say there was, so if you had k, a, m, and all of that to the power of n, where k was some constant, we'll apply the exponent to that front constant, and then also apply it, just like we did in the previous one, to the a, so it'd be m times n. So let's say I had 2, for whatever reasons, 2 to the, let's just put an x this time, 2 to the x cubed all to the power of 4. So that would mean that I end up with 2 to the power of 4, x to the power of 3 times 4, which would be 12. And if you wanted to, I didn't in the previous ones yet, but if you wanted to, you could write what 2 to the power of 4 is. So that is 16, x to the power of 12. If you have some number to the power of 0, it's going to equal 1 unless that number was 0. So 0 to the 0 does not equal 1, but everything else does. So 2 to the power of 0 equals 1, 5 to the power of 0 equals 1, if I did, doesn't matter. 8 to the power of 0, doesn't matter what that is, unless it's 0, of course, then it will equal 1. Now, continuing on, we haven't talked about what happens if you have a negative in an exponent. So if I had a to the power of negative 1, for example, what that means is it's 1 over, 1 divided by a to the 1. And in this case, that would just be 1 over a. So if I had a to the negative anything, then that becomes 1 over a to that power. So for example, I have 2 to the power of negative 3. That's 1 over 2 to the power of 3. And if you want to go further, you could simplify and write 1 over 8. Another thing that you'll have to deal with now is fractional exponents. So if I had a to the power of, let's say, 1 over m, so you've got a fraction in the exponent, that is the same as the root of a, where the root is whatever m is. So if I had let's say 3 to the power of 1/4, that's the same as the fourth root of 3. You could also have a to the power of an exponent that's a fraction with a numerator and a denominator. So in general, we could do m or n over m if you like. That means that you've got the root of m, but a will still have n on it as a regular exponent inside of that root. So if you had 6 to the 2/5, let's say, that would mean that you've got the fifth root of 6 squared. Alright, is there any other way we could write that? It's possible that the square doesn't go outside of it, so it is possible with that one. Let's say I wrote it again, a to the n over m. That could be written as like a to the 1 over m and factorize out the n, because remember in our previous rule we just did that if I put that in I'd multiply them together, and n times 1 over m would be n over m. And if we did that, you would end up with the mth root of a, all to the power of n. So I'll just do that one again, the 6 to the 2/5. You could have that as 6 to the 1/5 squared, and then that would mean that's the fifth root of 6 all squared. And that's the same as the one above. Alright, so let's try a few more examples now that we've went through these rules and see if we can remember them. So I'll start calling the examples here. So example 1, what would you do with 256 to the 1/8? Okay, so we should talk about how I do this on a calculator. So brought up the FX9750G2, which is probably the calculator you're using, and you'll notice that if I want to find the 8th root of 256 on the calculator, I want to use this button right here. And in order to get to that, I have to push shift. You'll see that shift's our yellow button, of course, and then push this key wrong color, this key right here, because you'll see that this symbol right here is above it. So before we hit that though, they want us to actually enter in the root. So what I would do is I would enter in 8, then I'd push shift. Okay, then I would push this button here, and then enter in 256. And then push EXE, and that would tell me that the answer is 2. Okay, example 2. Let's say we wanted to do the square root of 4x cubed times the square root of x to the power 5. Now the first thing I want to do is try to get rid of these roots. So remember that root is just the same as to the power of 1/2. So 4x to the power of 3 to the 1/2 times x to the power of 5 to the 1/2. And if I do that and then apply it, well, the half onto 4 is like the square root of 4, which is 2. X to the 3 over 2 times x to the 5 over 2. Now remember, if I want to combine these, because I have the same base, I can then combine it, and it's x to the 3 over 2 plus 5 over 2, which is 8 over 2. But 8 over 2 is just 4. So it'd be 2x to the power 4 as the answer. For example 3, the fifth root of x to the power of 6 over, alright, that fifth doesn't look, put a little higher, there we go, the fifth root of x to the power of 6 over the third root of x to the power of 2, so x squared. So how would I go about simplifying this one? I would, first step, get rid of these roots. So you've got x to the 6 over 5, because remember we could change that back into a fraction, over x to the 2/3. And remember, when we're dividing by, that's the same as subtracting. So we end up with x to the 6/5 minus 2/3. Now remember, on the calculator, if you want to do that, you can just use the ABC button to, so 6ABC5 minus 2ABC3. If not, then you could get a common denominator. So a common denominator with 5 and 3 would be 15. So the first one I'd have to multiply by 3. So that makes that 18 minus, and the second one would be by 5 is 10. And then that would be all over 15. That really doesn't look like an exponent. Make it higher. And then 18 minus 10 is 8. So it would be x to the 8 over 15. And I can't simplify that any further. The only other thing I'd like to say is if you want to enter in a fractional exponent on the calculator, it's really good to use brackets. So for example, let's say I wanted to know what 3 to the negative 1/2 is. So since that's up there, I like to think of it as actually having a bracket around it. So when I'm entering this into the calculator, I'm going to hit 3. Then we're going to hit the exponent button. Then I'm going to use bracket. Then put in negative 1, and then your fraction key, AB over C. And then 2 would work just fine. And if you do that correctly, you should get the same answer as if you were just working it out. So remember, negative means 1 over. 3 to the negative 1/2 is the same as 1 over 3 to the half. And remember, 1/2 is the square root of 3, so 1 over square root of 3. So if you type that in on the calculator and get the equivalent, you should get the same answer by writing in the above line, 3 exponent, bracket, negative 1 ABC2, close bracket. Alright, so give the next exercise a try and we'll see how it goes.